Hi, Jim Berthold here from OLI Systems. Today's video is about using the OLI Interaction Matrix. Now, to use the OLI Interaction Matrix, you first need to have the file viewer plugin enabled, and that's been covered in other videos. So the Interaction Matrix is a quick way of determining whether OLI has fully covered a chemistry. So we have a list of species here. In a single point calculation, water. This is MEG or ethylene glycol, elemental mercury, sodium chloride, H2S, and CO2. I haven't done anything yet here, so I'm just going to go ahead and calculate it. You notice that everything here is 0. To determine whether or not we have covered the chemistry from the interaction matrix point of view is simple, because we're going to actually have these interactions present in the model, even though the flows are 0. So we'll go ahead and calculate that. It is going to be very quick. It has to generate the model, and then it's done. So we'll go into the file viewer, okay, and we've seen some of this already. The file type will be called interaction matrix, okay, and we have a variety of things to look at. The first thing to look at is the parameters across the top. Now, I'm keeping this particularly short here, so it produces a good video, but we have the MSC. If you notice up here, we have MSC as our thermodynamic model. These parameters change depending on which model you're in. But I have the MSC parameters here across the top, and then we have a few more transport properties over here on the side. These are the actual binary interaction parameters that we have for the components in the system. For example, here, these are MSC type of components. We have a H2S molecular and an ethylene glycol molecular species here. And if I'm going to scroll on out, you see I have an X. This X is in the UNIQUAC parameter. So that means OLI has actually regressed the MSC binary interaction parameters for this particular couple in this system. And it varies, of course, what else we have in the model. For example, we have 2 vapor components here. Nope, that didn't line up very well. So let's try this again. We have in the vapor phase, we have a binary interaction pair here between CO2 vapor and elemental mercury vapor. We don't give you the parameters themselves. That just lets you know that we have covered the system. Now, these are only binary interaction parameters. We don't see the ternaries that are listed here. It's not possible to display them properly here. But you can do it by inference. If we have one and then the other, we probably have the ternary. But you should always test your own data to make sure that we have a valid set covered. One last thing to cover here is that we'll go back to the report, and we can customize the report here to looking at the species that we have here. I'm going to clear them all and just turn on speciation summary. Also, we give you a matrix. These are the species that are actually in the model. Okay. These are actually in formula view. You notice that in the file viewer here, these are actually in OLI tag view. So that means you do have to go back and change these to OLI tag if that's the way you need to see them. That's done through the names manager here. This is the icon. And we can change the type to OLI tag. So now it is exactly the same. We need to refresh the screen. There it is. What it appears in the report. So these are all the species we have by phase, and these are the binary interaction parameters that we have in the model. So it's a good indication of what we have out there. Again, we don't give you the actual parameters here. That's all for this video. Thank you for your attention, and we will post a new video soon. Thank you.